Hello everyone. Today I'll be talking about the DC motor and AC motor, and I will be talking about their differences and some of the statistics that they have. So let's get cracking. Oh, what is the motor effect? This is one of the most frequent questions that everyone asks. So the motor effect is basically a wire that's carrying a current creates a magnetic field. And this can interact with another magnetic field that causes a force that pushes the wire at a certain angle, and which causes the uh, coil to rotate. And this is what we call the motor effect. So as we see in the picture, this is basically the best demonstration of how does the motor effect works. We have the battery, we have the coil, and we have we have the permanent magnet over here, which we're gonna be talking more about them in the next slides. Uh, is that where people ask what are the components of a motor. So we have the coil that spins around, and this is basically the main part. And we have the two magnets on the side. We have the brushes here. These are these black things in these two pictures are the brushes, and we have the split ring commutators. We have the two batteries over here, which doesn't really matter. It could be one battery, two batteries, three batteries, but in this picture is two batteries, and obviously we know that this is the positive terminal and this is the negative terminal. So yeah, this is just a small explanation of what are the components. So how do motors work? So the current in the left side of this coil causes a upward force. But on the other side, the coil and the current in the right side of this coil causes a downward force. And as we all know, the upward force pushes it up and the downward force pushes it down. So it's going to rotate around, and this causes the motor effect that we are previously talked about. And this is how they basically work, and they rotate around constantly. And basically, in the next slides, we're going to be talking about how to use Fleming's left-hand rule to know how do they rotate and with which like components and these things do we use to make sure that we are right about their rotation. So then we have the question that people ask us, what is the split ring commutators and why does the motor need one? So split ring commutator are two metal half rings connected to the brushes. They provide points of electrical contact between coils and the external circuit. And the purpose of the split ring commutators is to reverse the current every 100 degrees so that the motor spins around constantly. It doesn't stop in one place. And uh, we have this question that how to use Fleming's hand rule to determine the direction the motor will rotate. And now we're going to talk about it. So basically, this in this picture we assume that this is the positive and this is obviously the positive, so the current is flowing this way. So we have our current right now. We have the middle finger over here, which is the current. We have the magnetic field, which is from N to S, which is our point finger, and then we have our thumb, which is the force, which is the place that's gonna like rotate. So now the current is flowing this way and the field is going this way. So if we use our left hand rule, our hand is going to flip around and we're going to say that our force is pointing down, and this should be the quite opposite, and this one should point up so that it will spin around. So that's basically how we use it. First we use our point finger. Then after we use our point finger, we will find the direction of the current. And then after we done these two, we will find the force. The what is like the question like what is the electromagnetic induction? So electromagnetic induction is the production of electromotive force, or what we call EMF, across an electrical conductor in a changing magnetic field. So what's going to happen is, if we want to explain, is that we assume that this is the north part of the magnet. So when it goes inside the coil cuts through the magnetic field lines of this magnet, so it will show a positive. current, and then which if we stop here, it's just gonna show neutral as it is right now, so no current is getting induced. And then if we pull it back, it's gonna go reverse, so it's gonna induce a negative current. So that's basically how uh, electromagnetic induction happens. And in the second picture we have the same thing but in the other way, so it doesn't go inside and out, it just goes up and down, but still the same. It's just gonna build positive and negative current. It's not, nothing's gonna change. It's kind of the same. And then in the other picture in the right, we have the main components of the generator. It's quite the same. We have the permanent magnets, we have the coil, we have the brushes, but in this line we call them slip rings. We don't call them split rings. We call them slip rings now. And then we have obviously our ammeter, and which shows that obviously the current that is flowing with these things. Then we have the magnetic field and other things. It's quite the same. Nothing like changed that much. Another question that people ask is like, what are slip rings and why do we even use them in AC generators? So slip rings maintain the constant contact with the same side of the coil, so these two things will never become disattached from one and go to the other. It will be always in the same slip ring, and as one of the side of the coil moves up through the magnetic field, a potential difference is induced in one direction. And as the rotation continues, we have it here, as the rotation continues and that side of the coil moves down, the induced potential difference reverses the direction. So it's just going to keep doing the same thing in our AC generators when we use them. So it's a vital thing in AC generators. And then the last question we have, the how like do we use the Fleming's right hand rule? So it's quite the same, it's just reverse, like you're just basically going to use your right hand. And obviously, if you know the left hand, it's going to be easy to determine the current in the AC generators while you know the right hand rule. So basically, we have the field, we have the force, we just have to uh, know. So basically, we will know the point again, and then we have the force. Then after we do this, we will find the current, and this is how we find the current in AC generators. And that's basically all of it. But anyway, I hope that everyone enjoyed, and I hope that I talked enough about all the questions. And yeah, take care, and I guess see you next time.